hide everyone here so I don't, so I can't see everybody. Okay, great. Thanks very much. So yeah, I'm Steve Matthews, and I'm really excited to be talking today. It's always great to talk to folks in New England. I did my master's at the University of Maine with Raymond O'Connor back in early 2000 or so, and at that time is really when we started working on this component of thinking about climate change in birds. So working with Louis Iverson, Matt Peters, and Ananta Prasad. And we've been asking some of these questions for quite some time. And so it's really great to be able to share this info with you all. So what I want to do today is really, sorry about that. But I don't want to spend too much time talking about climate change in forests, because really I just want to, hopefully everyone's been attending the webinar series thus far, because it's done a really great job of pulling together all the ways we think about climate change, how climate change is happening, what are the implications of climate change within forest, and the great way that these adaptation strategies are coming to play to maintain these healthy, productive forests. I just have the one image from Lewis's recent paper that really tries to pull together all these different species. I'm thinking about this in 1x1 degree grids to see these spatial patterns of how species, habitats, and migration potentials may change. So that's what I want to say. And if you haven't seen any of the webinars, then I would encourage you to go back. I've learned a lot by watching them as well. So what I want to do then is really kind of talk more about birds in this side, and then come back to really, kind of fit this in of how we think about birds and climate change. So just as a background, right, birds as a group have been in steep decline across North America. So the recent paper, hopefully folks have seen, but this estimate of 3 billion birds lost since the 1970s. And what I want to specifically kind of highlight is where forest birds fit into this. As you look, across this figure here, that's section D there, you see many of those aspects around forest. And really just forest generalists are, when we think about forest birds, are the ones that all the other forest type species have more than half of the species, proportion of species in decline, are in decline. And we can see this, visually by looking at breeding bird survey data and seeing the red areas, right, where we have, this is an example for Viri, sorry that got cut off there, of where that population has been in decline since the 70s. We can do that for all species. So as a group, right, we think about the importance of birds and that they are in decline. So this idea of creating conservation on the ground is super important. And then we want to think about climate change, right? And this is an additional stressor, right? There's many different ways in which birds are being influenced, habitat loss and change and many other components, but climate change is the other piece that we have to think about. So I just want to give a little bit and to talk a little bit about climate change as we think about birds, since it's a kind of slightly different processes than we think about within forest. So what I have here is an example of, we think about physiological changes, right? We can often think about these limits to metabolic processes. We can go back to I had a typo in there, 1980s, 88, when Terry Ruth's great research that really kind of identified these isoclines of physiological limits in winter temperatures for eastern phoebes. Forward ahead, 30 years now that we are, and in the new Audubon's survival by degree days really takes this into play. And that's the eastern phoebe here again, and we can see there where their habitat is currently and potential for range and expansion under climate change, right? That's an important component that we think about how birds respond to climate change. We also think about, and hopefully folks have checked out the Audubon survival by degrees aspect, and you see the large number of species that have potential declines in where they are occurring in their climate zones across North America, right? We can think of how those changes come about, and it really kind of underlines those basic metabolic physiological processes. The image I have over here on the side here really is just trying to highlight. This is actually just from a relatively recent paper that looked at cooling requirements in birds of the Mojave deserts. And what you see here is this y-axis, the x-axis, there are different scenarios of climate change under RCPs. The 3.7 degrees increase by the end of the century, 1.8 degrees increase by the end of the century. So these are RCP pathways that we talk about so much in the webinar. And on the y-axis, what they did for across birds was really look at this proportionate increase in cooling costs. So in terms of birds needing to seek out, spend more time trying to cool themselves down to try to maintain metabolism, maintain that survival mode. And we see they spent under the higher emission scenarios almost 70% more time trying to find places to cool down. So it gets us this idea of how heat stress is the way in which birds can be limited to climate change. And we see this, right, in terms of how it comes to play. And again, this relates back to this idea of body size and in terms of conservation of energy. In many studies across the globe and continents, different taxa of birds have kind of made this important link of body size changes and birds across their distributions as an important signal that birds are responding to climate change. And so those are a couple of the basic ways we can think about it. The other ways that I want to talk about really briefly, because it all ties into how we think about managing forest birds and why it's important that we have complex structure and habitats for these many different species occur, is also to think about the importance of full annual cycles. This is a really great diagram from a couple years ago. It's been followed up by the same team, looking at these kind of knowledge gaps and blind spots when we think about vulnerability. And in this case, right, thinking about birds being migratory and many of the species moving thousands of kilometers a year, and they're experiencing different climatic conditions throughout that annual cycle. So we can think about how wintering habitat climate can influence survival and energy components. We can think about how changing weather associated with more extremes with climate change influences both the ability to migrate in the fall and the spring, and we think how those carry over to influence their habitats on the breeding grounds, as well as how on the breeding grounds climate change continuing to affect resources for them. So we see these ways in which this full annual cycle aspect has to be incorporated as we think about climate change for birds, because they're covering so much ground in cases. Other physiological kind of responses that we observe, right, on the ground from many different studies, right, are these earlier arrival dates during migration, changes in hatching year and fledgling earlier as the climate continues to change. So we see that birds are responding to the signal of climate change already, and it's only going to intensify. And when we think about these physiological changes, right, yes, birds can respond in some ways to changes in climate, right? They're flexible, they can move around, which is great. But the issue is, can they keep up with the pace of climate change? I know this figure has a lot going on, but I just really wanted to include it, in part because I think it not only talks about birds, but in terms of the way the whole complex food webs are influenced by climate change. This paper is from the UK, and it really kind of breaks it down into thinking about primary producers, plants, primary consumers, invertebrates, in many cases, and secondary consumers. So of course, birds are fitting into the secondary consumer component. And what the key figure that we think about and we often hear about is, yes, plants and invertebrates. So we can think of Lepidoptera from many of our insectivorous birds, right? Certainly have this capacity to shift their emergence dates, the beginning of phenological seasons, right? We have a shift in abundance and occurrence to track when plants are coming out and leafing out by invertebrates. Yes, birds can respond, shift earlier, but they don't have the capacity to respond as far back as their food resource. And important to note, right here, right in New England and Hubbard Brook, right, we see that in North America, birds are not necessarily showing this mismatch in food preserving as much as we see in our European counterparts. And they really attribute this to this more diverse food base that we have in Eastern North America, right, as well as different bird densities. And that's really critical to this point. One is that we see these kind of breakdowns of when birds are needing food to feed their young, right, in the nest, and their ability to do that, and the importance that we have in the composition of both plants and invertebrate prey. So going forward, what I want to talk about here as we think about forest birds within the Northeast is really have this really diverse set of species, and there's these complex conditions occurring. And so how I like to think about it and how we like to think about it is we have the environmental conditions, right? And that is influencing the plant species composition in many ways, right? And that is creating a variety of structures and habitats, and birds are responding to both the composition and the structural components. So as climate changes, right, specific relationships between plants and invertebrate that birds feed on influence species. There's tight associations with different foraging guilds and types of species. And both this idea of composition and structure are important to think about as we think about how birds respond to climate change. So this idea, right, of maintaining structure and composition is really important as we consider different spatial and temporal dimensions of how species respond to climate change, right? Of course, birds could get up and fly, but the trees must stay in place. So how do these two kind of dimensions come together as we think about climate change? And so hopefully, right, this sets up where we have our climate change tree and bird atlas. And in this, we're trying to understand how birds, 147 birds, habitat respond both to a shifting climate as well as changing plant composition. There's an important link ecologically between floristics and bird species. We also know in many cases birds are really important indicators as in terms of both setting management goals and in terms of attaining them. And so that kind of using birds as this kind of picture of how the forest is healthy is important, and it helps us as we think about our forest management goals. And also, right, this idea that we can utilize this information, hopefully bring them into climate change vulnerability assessments and adaptation planning. So just as a primer for how our climate change tree and bird atlas works, right? It starts with our tree atlas, and we've seen some of that in the other webinar series, where we have a whole host of tree species where we've modeled environmental factors, climate, soil, landscape characteristics to understand the current patterns of tree species, and then projecting how those habitats would change under climate change. This is just an example for red maple. What we do for birds is we actually use that information of projected changes in habitats for trees and bring that into our bird models. So I just have two examples here. One, a southern bird, right, potential increases in habitats for solitary warbler. Another northern bird, potential increases, declines across their range in response to climate change under a lower emission scenario and higher emission scenario. So more climate change versus less climate change. And in this case, we see different types of trees coming into these different models, as well as this climate and precipitation signal. And so as we think about this, right, we can start to understand what is the relative importance of these tree variables in our models. So back in 2011, we had a paper in ecography, and we posed that particular question. And this is an example for black-throated blue warbler. So we have its current distribution in the top left here. Under current conditions. And then if we take that and we project it using climate, elevation, and tree information, we have a pretty large potential decline in habitat, 55% across its eastern US range. If we just use climate and elevation, well, that came out to be a 93% potential decline in habitat. And what it really begins to show us is that there's this really important dimension that the tree information is providing. It's providing us some information about on-the-ground habitat. And it's not just for black-throated blue warbler this appeared, but we looked across all our 147 bird species. We found that most species, right, fit in this no more change category. So what that means is we didn't include the climate change, they didn't include the tree information. Our models predicted more extremes in climate, either gains or losses. So it helps to temper that and create that on-the-ground link. So what we've been doing in the past is how we think about this. And another way I want to illustrate why it's important that we're thinking about what trees are saying in terms of these habitat models for birds is we have the current distribution of black-throated blue here. That's going to be this green line. What we typically do is then simply take the proportion of how that habitat is going to change by the end of the century. In this case, I'm just going out to 2070, which really isn't that far away, right? And we see this potential decline in habitat. We see much more yellows kind of in that piece. But if we want to really understand how these scenarios may play out, right, we want to start to think about how does this follow along a trajectory. So if we do this in 10-year pieces, we can see a relatively consistent decay across the next 70 years in terms of habitat conditions, right? And we get a sense for this role. And by doing this, right, we can estimate what happens under these different conditions. So the first questions we ask are, how would the trajectory look if we only use climate to project how habitats would change for black-throated blue warblers. What we find here is the red, that if we just use climate, right, we have essentially a 65% loss in habitat by 2070 for black-throated blue warbler. By using the tree information, that there's still a large decline, right, but it's relatively, it's reduced. And this kind of gets us the ability to start thinking about different scenarios. And in this case, what we're saying here, right, we have our climate-only model, we have the model in the black line there is taking if we allow the trees to also respond to climate change. And the blue here is if we're somehow able to think about maintaining the current composition of plants on those locations, so a much lower decline. And so what I'm really trying to get at here, and what we start to see, is how sensitive these individual species are to how much change is occurring within the forest in these situations. And so what we do is we line this up across 88 forest birds that occur within the Northeast, and we see these really interesting patterns. We see species as we're on the left side, species that have these increased associations with specific tree types, right? They're more sensitive to how much change is occurring in the forest. If we move all the way over to the right side of the screen, here, something like a black-billed cuckoo, their model really is very similar whether we have tree information or not. So it's not using that tree information. So it's important to understand that species respond differently and in unique ways to climate change. So where am I going with this? Well, what I want to do is just to really kind of relay this to the forest adaptation process. This is an older slide, but really how it fits into the vulnerability assessments and how we can start to think about where birds have a role in thinking about how we're adapting our forest when considering climate change. So we all know the great NIACS frameworks that have brought people together to think about the implications for climate change. And then the next step that many of you all are in is taking those next steps of formalizing adaptation plans and strategies, which is so great to see those collaborations and how much great work is being done by everyone on the ground. And so just as a quick primer, right, when we think about the New England assessment, I just pulled out the southern and coastal New England kind of sheet here, right? And we can think about the different tree species and how they're projected to change in habitat, from likely decreasing, like balsam fir, to species that have potential to increase and potentially move into the area, such as increase in terms of white oak within those places. So how can we bring birds into the mix? Fortunately, right, there's many great examples, and I just have just a couple examples here because I really just want to focus on Mass Audubon just to really link in with Tom's presentation here, as there's these strong links between forest management and birds. So here in Ohio, our Managing Forest Birds, Southeast Ohio, that was initially created by Amanda Rodwell and it's been continued on by Ohio Bird Conservation Initiative, Matt Schumard coordinating that in terms of thinking about how we manage our forests in Ohio for birds. Vermont, right, Vermont, New York, Audubon, Michigan, Maine, many other states, right, have these important programs where we think about silviculture with birds in mind. And so what I want to do here is just walk us through how we think about these 17 birds that are in the Massachusetts Audubon Managing Forest for Birds and where they fit within our assessment. So if we look at our typical tree output for the New England assessment, right, we have these potential species for increasing, declining, staying about the same under different under climate change. So increasing by 20% to decreasing by 20% is a kind of our threshold for the arrows, right, in terms of red, green, up and down arrows. And if we look at the Mass Audubon list, right, we actually have modeled 14 of those 17 species. So what I've done here is I've just kind of done similar annotation across this. And what do we notice initially from this figure? Well, we noticed that across these 14 birds, under most scenarios, and especially under the high scenario, most of them have these projections for at least declines of 20% of their habitat, which is a pretty significant amount, right? Only 3 birds, brown thrasher, eastern towhee, and northern bob white, have the potential to increase in habitat within New England over the next 100 years, according to our habitat projections. So it's a pretty large list and pretty interesting component there. So if we want to look at this a little more in detail, right? And just to pull out a couple of examples of hopefully how we can think about how this blending of understanding silviculture, actions on the ground, and how that can influence habitat for these birds is really important for conserving both birds and maintaining productive, healthy forests. So if we look at black-throated blue warbler, across New England, the habitat models would suggest a potential for decline by the end of the century from 0.72 all the way down to 0.34. So one would be habitat staying the same, depending on the emissions scenario. And that kind of gets to this idea of changing habitat conditions. What is also of interest is to think about how our habitat models across the range are working. And we see these really strong associations with mixed forest types. So we have black spruce, yellow birch, but also really important in our model comes to this importance of striped maple, right? So it kind of gets at that structural complexity that black-throated blue warblers are using, as well as climate determinants. So our model at this distribution level is matching and picking up some of those important dimensions we see in the forest management guide. Another example would be Veery. In this case, we have a potential decline across New England. So that's the vulnerability assessment region, I should say. Again, similar potential declines in habitat that we saw black-throated blue warblers, but we see a different host of species, right? This more wet forest type conditions and hardwood type forests are really showing up as being important determinants of the models. And so we have some confidence that they have some applicability within the region, and we see the potential for large declines, especially under the higher emissions scenario. Another species that goes the other way would be the eastern towhee. So like as the question started off, the poll, the drink your tea bird, across New England has a potential to increase in habitat under climate change moderately, right? So 1.3, so that's about a 30% potential increase in habitat. And what we see here is that climate variables show strong predictions within there, as well as in the southern portion of its range, right? The importance of yellow poplar. So we can think about where does yellow poplar occur on the landscape? Well, it often is coming in these very dense, high numbers of stems, after an opening, as that forest kind of begins to respond, whether it's after a harvest or disturbance. So that type of really dense, thick understory habitat we see showing up within our models. And so what I want to do, these are just 3 examples, and we can continue to do this, and it'd be fun to talk more about how these work and come into play. But what I want to do, and as I'm running out of time here, is just to think about how this kind of folds back into how I started. One is that when we think about birds across North America, we know that many of them are in decline. So these are just those actual change maps, and from the breeding bird survey data on the top here for both eastern towhee and Veery from the breeding bird survey data, right? So they are in need of conservation action, and that's why, right? And it's great to see them in the forest management plan for Vermont and many other locations. We also see, right, for some species like eastern towhee and even brown thrasher, under climate change from our models as well as from the Audubon assessment, they have the potential to increase to some extent within New England, or at least maintain their current habitat conditions. And so while they're projected to decline across their entire full range, they actually have this important, New England serves as potential important location under climate change where their habitats may remain intact. So managing early successional types habitats, as well as maintaining substantial increase, maintaining mature overstory habitats is really important to have this blend of conditions for species. And the last part that really relates to this too is that these species presented here, right? So similar patterns and really regional importance within New England. So really, as we think about as the habitats change under climate change, New England's already an important location for forest birds, and it'll only become more critical as our habitats continue to change. So what we can do now to maintain healthy habitats, forest habitats, is going to be important for birds going forward. And so with that, I was kind of in with a couple of takeaways. One, New England's a really critical location to consider the climate change responses. This great kind of diagram from Josh Lawler's group, kind of showing this flow of pace from migration. Birds are in blue here. As we think about climate change, funneling through there, all the great work from the Nation Conservative that shows important connected landscapes within New England. We can think of how this relates to all the really, not only in terms of climate change, but all the really great research that's conducted in New England. We think about the connectivity and capacity and landscapes. We have a UMass thinking about all the great work there, how it links to long-term research, specifically at Hubbard Brook, where we have this really great understanding of how birds over the long term have changed and responded to shifts in habitats, how populations cycle, right? It's just a really great place and a leader in how we think about both forest and bird habitats, but also climate change. So my conclusion here is really considering both these near and long-term processes. Birds are declining. We're having on-the-ground conservation action to increase those numbers, and it's going to become more important going forward. And to do this, right, silviculture is really going to matter as we consider now and going forward into climate change for both trees and birds to meet our management objectives. And creating these diverse structures and plant communities, it really comes out, right, in terms of how we think about responses to climate change and working together to make sure we get there. So with that, I'm going to say thanks and turn it on over to Tom.
Awesome, thank you. That was, wow, there was a lot of really good information there. Yeah, Tom, feel free to start sharing your PowerPoint. We'll get you going. So again, if you have questions, please feel free to type them into the chat box, and we will start addressing them as soon as the presentations conclude. All right, Tom. Tom, you're muted. Let's make sure we get you unmuted. There's always the bottom. Oh, Tom, there's always the bottom.
It's at the top. I'm okay. All right. Thank you so much. Appreciate that. I want to say that I'm really grateful to have the opportunity to present in this webinar series. As a practitioner, there's a huge volume of information that the research community is coming out with. I'm really just hugely grateful to folks like Steve, who are coming up with great information for us to consider as we're trying to come up with management decisions and applications on our lands. Also, in particular, I'm grateful to be doing this for NIACS. That community has been so supportive of our thinking, and as we wrestle with climate adaptation decisions on our lands. So it's great to be able to give back to this community a little bit. By way of introduction, I'll just mention that Mass Audubon is its own organization independent from National Audubon. And our mission is to protect the nature of Massachusetts for people and wildlife. To do that, we have strong programs in environmental education, conservation advocacy, and land protection. And central to this mission is our wildlife sanctuary network. The network includes 105 sanctuaries scattered across the state, so from the coastal regions out through the Berkshires. And it totals around, as Amanda said earlier, 38,000 acres of land across the conservation portfolio. So in my view, the responsible stewardship of that land base demands that we understand and anticipate the effects of climate change in the state, and to manage the sanctuary network to support native biodiversity broadly in the region as climate changes. So in a couple of minutes, I'll focus on bird habitat and forest adaptation project that we are doing here at our Elm Hill Wildlife Sanctuary in Brookfield and North Brookfield, right there in the central part of the state. But first, looping back to some of what Steve covered, I'll touch on some of the science that Mass Audubon has conducted of our own that guides our ecological management thinking. So from its earliest days, Mass Audubon has focused much of its efforts on bird conservation. In the past decade or so, my colleagues have published a series of reports documenting population trends and their conservation implications for bird life in Massachusetts. In particular, the State of the Birds report calls attention to general trends of long-term population declines in bird species that breed in grassland and young forest habitats, long-distance migrants, aerial insectivores, and ground nesting birds, among other groups. The most recent report in 2017 presented a climate envelope analysis of 143 bird species that breed in a state and provide us with state-scaled insights into the climate vulnerability of these birds. And I view that as additional layer of information that complements the work that Steve presented just now on his climate vulnerability assessment. So this is some of the results of our in-state analysis. But I'll say that for me, the climate envelope analysis and combined with previous research reveals a complicated conservation future for forest birds in Massachusetts. So I need a much larger matrix to present all the different combinations. I think Steve was kind of getting at, but as examples, model results indicated that some species with currently stable or increasing population trends could decline by mid or late century as climate changes continue, while other species might face a double whammy of both long-term population declines, say from habitat loss, in addition to climate-driven stresses. So while these results tell varied stories, I'd say it's important to keep in mind that as a rule, bird species with increasing population trends are more likely to fare well as climate changes, simply because they have, there's more individuals, larger numbers of individuals, fanning out through the landscape to find the niches they need, suitable habitat conditions to increase their populations. To me, this indicates that we need to do what we can to reduce non-climate stressors wherever we can, giving as many species as possible a chance at making it through the coming climate changes. And for many species, that means that active habitat management can provide a meaningful boost.
Hey, Tom, I'm sorry to interrupt. We're having some sound distortion. I'm wondering if you could turn off your camera and we'll see if that improves the internet connection. It's annoying because it's worked perfectly fine during the tech check. But if you turn off your camera, then your audio might work a little bit better. Let's see if we can do that.
Is that better?
We'll see how it goes. Let's keep going from there. Thanks.
Thanks, Amanda. Of course, not all declining bird species are declining for the same reasons. Population declines in bird species associated with young forest habitats, for example, are associated with a lack of suitable habitat or a decline in the available area of habitat, while declines in bird species associated with mature forests are more associated with potentially poor habitat quality for a variety of reasons. So fortunately, silviculture can be applied to address both of these situations depending on the design and intensity of harvest. So our Foresters for the Bird program is implemented in Massachusetts by Mass Audubon and conservation partners, trains foresters to conduct bird habitat assessments in their forest stewardship planning process, and incorporate silvicultural treatments to provide needed habitat for suites of species of conservation concern. I just briefly tip my hat to Steve Haugenbuch, who's of Audubon, Vermont, who's I think on this call, for helping us import a great idea into this state from Vermont. For some reason, my slides are no longer advanced. Here we go. All right, so getting to our case study, one of the main questions that folks were asking us participants in the Foresters for the Birds program are asking us, as well as Mass Audubon, doing any of this work on its own property. And we can answer in the affirmative here at our Elm Hill Wildlife Sanctuary in Brookfield and North Brookfield. And this is a phenomenal property. It's roughly 1,100 acres, about 830 acres of forest, 210 acres of open fields that are split between hay fields and row crops. And there's about 60 acres of open water wetland. It's just a lovely property with a whole suite of really interesting features. It's got complicated topography from its underlying geology as a drumlin swarm. Got cold water streams, priority natural communities, and rare plants. Whole scattering of vernal pools, populations of grassland birds and shrubland birds. It's a really great place to think about all this stuff. It's, I think, a fine example of a abandoned, former agricultural land, kind of classic New England forest. It's a transition hardwood forest, largely with a high diversity of trees based on microhabitat availability. But due to its agricultural history, the property faces a range of challenges as well, including healthy populations of invasive plant species, certainly invasive invertebrates like emerald ash borer afoot in the landscape, white-tailed deer overpopulation, and deer browse pressure is an influence on the sanctuary as well. The property, I should say, is covered by an agricultural preservation restriction, which includes forest products. So we're excited to use this, actively manage this forest for forest products as a way to meet the terms of our agricultural preservation restriction. That's a lot of information. We've hired a consulting forester, Mike Barry of Bay State Forestry, to help us work through some of our forest management decisions on this property. We initially hired him to do a forest stewardship plan, which is a 10-year plan, but we asked him to expand that to incorporate climate change. So we asked him to think about a 100-year planning window for this property. And once he created his plan, my colleague Jeff Ritterson and I ran that forest stewardship plan through the NIACS adaptation workbook process as part of our kind of practicum for one of the NIACS adaptation training webinars. And if you have the opportunity to take one of those, I'll just put a quick plug in for that. I really strongly encourage it. It's been a huge help for just helping us sort through a massive amount of information and distill it down to various layers of strategies and approaches for making decisions on this property. So to get to the results of all this thinking a little bit, our forest management project here at Elm Hill, our goals, broad goals, are to achieve wildlife habitat and climate adaptation. So that's enhancing the forest structural and compositional diversity, to increase the forest's ability to tolerate climate changes, managing invasive plants to safeguard the forest's integrity, and demonstrating sustainable forestry practices to increase habitat quality for species of conservation concern. So our methods there are a variety of forest management treatments, invasive plant control efforts, and reserves in appropriate areas, as well as just careful application of best management practices as the harvest proceeds. To boil it down a little further, if you're familiar with the adaptation workbook framework, we have our management, we've identified our management targets: transition hardwood forest, invasive species, young forest bird habitat, sensitive natural communities. I guess I should add mature forest bird community habitat to that as well. So just to take one of those goals regarding invasive species. We're looking at invasive plant management to maintain good forest health, improve wildlife habitat, and maintain productivity in agricultural areas. As we certainly are aware that as soon as we do any timber harvest there, get some more sunlight on the ground, we'd really be opening up Pandora's box even further for the spread of invasive species threatening the forest integrity in the future. So we've been fortunate to have 2 full seasons of invasive plant management treatments in the areas where we're conducting harvests. And that's made a huge difference in just the the biomass of invasive plants on the site. Another goal is to promote the development of structurally and compositionally diverse forests. So we're focusing on a 70-acre area of young forest habitat to complement the existing agricultural fields, and enhancing structural complexity of the closed canopy forest to support species like the black-throated blue warbler through more selective harvests on 80 or 90 acres. Some of that harvest includes, the wholesale clearing of old pine plantations or old field pine to facilitate sort of a more natural composition on those stands. And throughout all the active harvests, we'll be following best management practices with respect to soils and hydrology, wetlands and waterways when we're conducting forest activities. This is a little brief summary of the map from our forest stewardship plan showing some of our wetland systems, and we've identified the vernal pools. The site has some woods roads and old skid trails and former sort of farm access roads kind of snaking through the property. We've expanded our logging access system like off of those existing roads where to the extent feasible. So we're not, we're trying to limit our road system to the extent we can. We've got areas where we're proposing no cuts based on vernal pool complexes and so forth. So this is a lot of information, but it's all fed into some of our silvicultural prescriptions. Coarse scale, we've got our clearing area to expand young forests and early successional habitat in general, or expand the area of habitat available for young forest species in the southeastern part of this active harvest area. In the kind of middle band, the green, we've got a selective harvest of various intensities. And in the northern section, we're doing a structural complexity enhancement cut to kind of promote the development of old growth forest conditions. And that's not a silvicultural cut. It would just be, that is, there's no wood is being actually removed from that area. It's all going to be left on the site, about 10 or 15 acres for that. So we're demonstrating here a variety of intensities, a range of intensities of harvest activities, different methods to try to complement the existing features of the property and take advantage of opportunities to enhance habitat for target species where possible. Operationally, we were hoping to have our cut done by now, but this is how it looked over this winter. We had, of course, a very mild winter with very few frozen ground condition days. Our logger was able to get to the site really for only a handful of days, and he mobilized and demobilized and mobilized again and demobilized again, and I was shocked actually at how much work they were able to accomplish despite being on site for such a limited time. But we felt like we couldn't allow them, or they made the decision as well, to not continue the harvest when the ground wasn't frozen to avoid permanent or long-term damage to the soil. But I was very pleased with the results of the harvest so far, and I'm looking forward to things drying out hopefully this summer and completing the harvest there. This is a mechanical harvest so far with the feller buncher, and the more selective cut will be conducted through it'll be a cut to length operation. So one thing I want to say is that Mass Audubon is attempting to use this site, as I say, as a demonstration project. We've hosted the Northeast chapter of the Society of American Foresters meeting on the site to talk about climate adaptation and bird habitat management here at this property. And the project really couldn't have been undertaken without the support of many partners, including the National Fish and Wildlife Foundation, the Natural Resource Conservation Service, Mass Wildlife, DCR, and our consulting forester. And I also just want to again thank NIACS and Maria in particular for all the time that they've helped us think through our silvicultural treatments and just conduct as exemplary a job at this property as we can. So I'll end there, and thank you for your time on this beautiful spring afternoon.
All right, thank you so much, Tom. We did have a little bit of sound challenges, but despite that, folks had some questions that are coming into the chat window. I think given the time, we'll try to just keep rolling with the questions. So let's see. So just first for the record, Andrea had asked of Steve if he could expand upon the Bird Atlas model reliability, and Maria shared a link, and also Steve replied in the chat box. So we had some info there. So for Tom, we had a few questions come in about the 70-acre cut. I'll ask one at a time. The first was from Nicole Sanford. She asks, what are the invasive species and what specifically is being done to manage those species? Are you concerned with deer herbivory after the 70-acre cut?
Certainly, deer herbivory is a concern on this property, and we're working to manage that issue. In terms of invasive species, some of the dominant invasive plants on the property include glossy buckthorn, common buckthorn, oriental bittersweet, and there are some really champion buckthorns on the property, like tree size plants. We've managed those through a variety of treatments, mainly through herbicide, which has been effective to the extent that we've applied it. I see a question about that patch seeming like it might fragment the interior forest. We designed the young forest cut essentially to push out the field edges that were already were kind of historically present on the property, and the field edges had grown in over time. So we're just expanding out to bordering stone walls and clearing out some of the plantation areas as well. So I feel like there's enough intact, mature, there's enough of a forest block remaining there that I'm not too concerned about interior forest birds being affected by by this particular harvest.
Okay, great, thank you. You might get a few more questions on the treatment, but I'm going to pitch the next one to Steve. So Karen asks, Steve, do your models include impacts from invasive forest insects in their management scenarios?
That's a great one. So yeah, so these models specifically, we don't have invasive components. I mean, some of our other tree work, we certainly do like to think, we try to address how, how invasives, come into play and potentially change the components. So we've done a good bit of work here in Ohio with animal ash borer and then how that kind of impacts kind of carry forward. But so these models, how we view them as, these are our, current conditions. And like we've done with the trees, we've also think about these other modification factors. These are life history characteristics, these other changes that occur on the landscape and how that change our interpretation. So it's a really important component, to think about, right? So, so a good example of that is, sort of in some cases where, something like ash would show up as an important variable in our model, right? We would either, we can address that and as it projects forwards, because we know in reality, ashes are really not doing so well, right? We're ash borer here in Ohio, especially, and as it expands further. So we can take those into account to some extent. They're not directly into the results I presented today.
Great, thank you. Let's see, we had, I'm trying to distill some of the questions that came in for Tom about the management. One was about, can you speak a little bit about what the structural complexity enhancement involves? And there might be other folks here that can speak to structural complexity enhancement as well. But Tom, what can you tell us about that?
Sure. Now, one of the slides there had Paul Catanzaro of UMass, who came out to the site with us to really, kind of help us really think through operationally what a structural complexity enhancement cut would look like in detail on this property. And we're thinking about essentially cuts with, hand cuts, chainsaw work to fell a number of trees in clusters to kind of recreate small gap, kind of a small gap disturbance, potentially girdling some trees to increase the amount of standing dead wood, leaving a lot of coarse woody debris on the ground, leaving all the coarse woody debris, in fact, from this area on the ground, to increase that habitat component. Those, I think, are the most important factors or ingredients in that prescription.
Cool, thank you. We'll let folks take a moment to type additional questions into the chat box. And I apologize if I didn't quite get to exactly what your questions were so far. Trying to synthesize, but I also want to point out we do have just a couple minutes before the top of the hour, so if you're going to jump off, if you're seeking SAF credits, Society of American Forester credits, I did paste a link into the chat box that's a certificate of credit assignment, so you can keep that for your records. And anybody who participated for most of the webinar in today's program, I will submit your name to SAF, so that will be included in your member record. All right, let's see, are there any additional questions? And for folks that did ask a question, let's see, aha. Oh, and will we please forward all the resource links to us afterwards? So yeah, again, we will post all the links that have been shared on the NIACS webpage, so forestadaptation.org/NE-webinar, where all of the webinars will be found. Oh, and Maria's already there. Great. Do we have additional questions for our presenters? I know there are a lot of really good bird folks on this call, so if you have questions or something, feel free to pop into the chat box, or if you want to stick around and chat, you're welcome to as well. Maybe everybody wants to get outside and listen to their forest birds. All right, great. I think, Steve Hagenbu is asking, how will the young forest be maintained? So Tom, do you want to address that real quick?
Sure. Well, and young forest is an ephemeral, as you know, an ephemeral habitat condition. I'm not sure that our long-term plan is to maintain all of that area as young forest. For example, the red pine plantation and white pine, old field white pine areas will probably allow them to succeed back to forest over time. But the areas that are immediately around those agricultural fields, I do think that we will be maintaining a margin of young forest area around those over decades. So that will probably be, we'll get 10 or 15 years of good young forest habitat out of that, and we'll probably start to implement kind of rotating patch mowing with a forestry mower over, some proportion of that area on a cycle, maybe every 5 years or something like that. So we have a staggered approach that we don't have to do all, 50 or whatever acres all at once, but maybe 20 acres at a time or something like that. So that's kind of the current thinking. It may evolve. It's all resource dependent as well, not owning a forestry mower.
Indeed. Yeah, I think the classic answer is it depends. So
Yeah.
thanks. All right. I see we are at the top of the hour. So if people need to jump off, please join me in a virtual round of applause for our presenters. And we do have a couple more questions. So we'll, anybody who's able to stick around, we can get some answers to that. But if not, thank you so much for everybody for participating in today's webinar, and check out the future ones in the series and all the resources on the website. So I will continue. Yay, Jake is applauding. All right, so we had a question, can the ag land support grassland nesting birds? If so, how would those be managed?
The grasslands or agricultural lands on the property are currently leased to farmers. And we have basic control over some of their activities and less control over some of their other activities, I guess. I would say that embarrassingly, not all of the agricultural activities are as well aligned with grassland bird conservation as I would like, in that there's some, for the most part, the mowings that occur on the property are late enough to allow, say, bobolinks and savanna sparrows to successfully breed and fledge. But that's kind of a quirk of the way this farmer operates, as opposed to a sort of condition in the lease right now. So I'm hoping that we can work with the state's agricultural Department of Agricultural Resources to kind of more closely align the agricultural practices on this property with grassland bird habitat needs.
Great, thank you. I don't see any other questions in the chat box at the moment. Probably as soon as I stop talking, one will appear. That's how it usually goes. But yeah, we had, just again in sum, we had some really great questions. There's a lot of resources for folks to check out that we'll post on the website. So yeah, once again, thanks to Tom and thanks to Steve for taking the time and being indoors yourself for this hour. We hope you get out to enjoy your forest birds. And thank you for your work and for sharing your work.
Oh, it's a pleasure. Thank you very much, Amanda.
Yeah, thanks very much.
Thank you.